Okay, so in Resource Monitor, I can look at my memory usage, and there's all the applications and data that are open and are present in memory. But what I've got here is a nice graphical representation, so I can see my currently active applications and data are occupying this green area. This blue area here, this dark blue area, is no longer in use, but the applications and data that were there have not yet been deleted, because often if you've used an application recently, you are likely to open that application again. And so by keeping those instructions and data resident in memory, you can speed up the system. The last bit of RAM here is completely free. So this blue area is not actually required, is not actually essential, and we can load more applications and data into but through double clicking them, and they'll be loaded into RAM. Where the applications go into RAM is all managed by the operating system. If the RAM fills up, the operating system will automatically start to bring virtual memory into use. And again, all that is done automatically by the operating system. The people who wrote and designed these applications here haven't had to worry about that at all. Now, as you know, the reality of how data is stored on a hard disk drive is that the noughts and ones are represented as patches on the surface of the disk, patches of magnetized and non-magnetized area. Now, to make it much easier for you to visualize and manipulate that data, operating systems provide a file system, as you can see here, and it typically involves folders, and inside of the folders we have individual data files. So that's a very important, maybe it's very familiar and so easy to forget how important it is that the operating system provides a file system. So as you know, computers are at their most powerful when they're networked, and this is all managed by the operating system as well. So here's my network and sharing center. This is my Wi-Fi status, and I can look at the properties, and I can see that my Wi-Fi connects using the transmission control protocol and the IP protocols within that, and that's version 4. So that's the original version of the TCP/IP protocols, and it also uses version 6, although most websites don't use that yet. It's still needed as it's brought in more and more over the next few years. So the protocol stack of the application protocol, the transport protocol, the IP protocols, and the network interface protocols, they're all contained within the operating system. This means I can do clever things such as set up a home group and share data on a home network, and it all happens invisibly and seamlessly with no effort on my part. I can also use the internet, which relies on IP protocols, and all this happens invisibly and effortlessly due to the networking facilities that the operating system provides. Even on a home PC, you are still able to manage user accounts and passwords. So I could add a family member or someone who wasn't in my family. I could assign them a username and a password. I could control which directories that person had access to, so that's their user account permissions. And of course, if this is done centrally on a network server, then that makes it much more powerful. For instance, in a school where you can automate the process of creating lots of accounts for new students, and setting standard permissions for those students. So we'd put them into what we call a group and say, right, anyone who joins as a student can access these student shared areas. So all this ability to set up accounts and permissions is all handled by the operating system. So anything attached to the PC is called a peripheral. So a printer would be a typical thing, and if I plug the printer in, it automatically gets picked up. The driver software that allows the operating system to communicate with the printer will be automatically loaded, so that then that gives me the ability to set things like printing preferences, and all that happens, and all that is provided by the operating system. If you plug further devices into your PC, so if I reach down and plug in a hard drive into this PC, as we can see, it's opened up a directory, and we can see here it's appeared showing what type of drive it is, how much space there is, how much is used, and all that is handled seamlessly and effortlessly by the operating system. So that's peripheral management. So here I've got a Python application. I've imported the time and random modules, which are full of functions that I can use. I'm now printing a random number or a random integer between 1 and 10, and then I'm just sleeping, or rather waiting, if you like, for 1 second. So the result is every second it prints a random number. There is no point in the program where it asks me for an input or anything that I can do to stop this. So to stop it, I actually have to interrupt it. And the way I can interrupt it is to click on this button with my left mouse button. I can click abort debugging. And as it shows, it's sensed the keyboard interrupt, and the application has been halted halfway through the loop. This is the task manager, and it shows all the different applications currently running on the CPU. Each application will get between 10 and 100 milliseconds on the CPU before it is interrupted. Its status is saved, and then the next application is run. So in order to get through all the applications quickly, so they all feel like they're being served by the CPU properly, they are stopped and started very rapidly, and the act of stopping each application requires what's called a software interrupt. So software interrupts are happening rapidly and continuously as part of the normal operation of the CPU multitasking.